Section 3.4 is the chain rule, and the chain rule is definitely one of the harder topics that's covered in Chapter 3. Students really struggle with understanding this, so the more practice that you have, the better off you will be. So it says if f and g are differentiable, then the composite or the composition function f of g of x is also differentiable. And so in order to take the derivative of this, you take the derivative of the outside function, leaving the inside function the same, times the derivative of the inside. It's written in words also down here, but this is definitely something that we need to know. It says the chain rule says to take the derivative of the outside function while leaving the inside function the same, then multiply the derivative of the inside. So down here is the first example. We have to first understand what composite functions are or composition functions are. So there's a list of functions in here. So going ahead and figuring out what's the inside function that we have here. The inside function that we have is 2x plus 3. And the outside function that we have would just be x to the 7th. And so if you guys were to think of putting that inside function into this, the composite of it. So likewise, we have the inside function here is going to be 4x to the 3rd minus x, and our outside function would be the square root of x. Down here, we have t squared minus 1 is going to be our inside function, and our outside function is going to be the 2. T to the negative 5th. Down here, this one needs a little bit of thinking about. Again, with trig functions, a lot of students get a little mixed up here, but 2 theta squared is our inside, and then secant of theta is on the outside. For the next one, I'm going to rewrite this just to kind of see it. This is the same thing as sine of x squared, which there's a note up at the top of the page kind of discussing this. So our inside function is actually sine of x, and our outside function is x squared. The last one here that we have, our inside function is actually going to be the exponent. It's x squared minus 1, and then e to the x would be left over, which is our outside function. Okay, so derivatives of exponential functions. We have seen the first one already. So it says if you take the derivative of e to the x, it's just e to the x. Now, the issue we have now is that with the chain rule, we can take the derivative of e to some function, say g of x. So again, e, taking the derivative of our outside, e, the derivative of this would just stay the same, times the derivative of the inside. So let's go ahead and try the 2 down here. So these are following along exactly with what we did up above. So taking the derivative of this, so we leave the inside function the same when we take the derivative of the outside. So if you have x to the 7th, it would have been 7. It says to leave the inside function the same, raised to 6 times the derivative of the inside, which is just going to become 2. And then see if you can clean that up. The next one, again, you can rewrite this as 4x to the 3rd minus x raised to the 1/2 power. So y prime or dy dx is equal to 1/2 times, leaving that inside function the same, subtracting 1 from the exponent with the power rule, so negative 1/2 times the derivative of the inside function, which is 4x cubed minus x, which we get 12x squared minus 1. So again, cleaning this up, we do not leave anything with rational or negative exponents, so this is a good one to check to make sure that you understand the rules of exponents. So this is an introduction for section 3.4. Try the next couple examples, and there'll be some more examples posted on Canvas.